Hi, I'm Bill from ET3 Design. We're here to introduce you to our new Stage 2 fuel pump control module. A few months ago, we released this high performance module, and right away I got questions about whether it could drive a Stage 2 fuel pump. Well, it kinda can. For sure the stock module cannot. The stock module will cut out at 20 amps. We won't be able to show you that running in a car later on. This module can run at 22 amps all day long without a thermal shutdown, and can run temporarily up to 40 amps without shutting down. However, it doesn't solve all the problems or challenges that these Stage 2 fuel pumps put on the control module. So, talked to a lot of customers, and we designed this module to address all those concerns. So first of all, the Stage 2 fuel pumps can draw anywhere from 18 to about 26 amps, depending on the flow and the pressure demand on the fuel pump. So this module is able to drive 35 amps under all thermal conditions and has no problem driving a Stage 2 fuel pump. The way we do that is internally we've added a couple heat sinks on a couple of the critical components. We've added a small active cooling fan, which is temperature controlled. It runs at 2 speeds. Starts off really low for low temperature, and if the temperature inside gets a little higher, it kicks into high speed and cools it. The upper current limit on this, or actually fault limit, is 40 amps, and we can also probably demonstrate that in a future video. We'll show you that this running at 35 amps and cutting out maybe at 40. Additionally, we added a terminal block for the high current wires because the connector can't really handle the additional current. Seen a lot of people complaining that the connector can melt, and one guy said it was smoking and concern of actually starting a fire. So this terminal block can handle that current with no problem. We're going to do a little demonstration for you today. We're going to show you how the OEM fuel pump control module isn't really able to drive a Stage 2 fuel pump. So I'll go through the setup here before I start the car, and I have actually some waveforms and voltages to look at so you understand what you're seeing. So the fuel pump output on the control module is right here. There's an oscilloscope probe connected to that output, so we're able to look at the actual drive voltage waveform on the oscilloscope here of what the fuel pump's actually seeing. We also have a current meter that's going to measure the output current through an inductive pickup of what's actually driving the fuel pump. Then we have, hooked up to the ODB2 port, we have the scanning tool that's going to show us live data of the voltage and current on the fuel pump. This car actually has a OEM style aftermarket fuel pump in it. So it won't drive the level of the Stage 2 fuel pump, which is good in this case because we're going to show how the system operates before it goes into fault condition. In order to get into the fault condition, I'm going to increase the load current on the fuel pump control module using this resistor bank. So when we get up to about 20 amps, you're going to see that the fuel pump control module goes into a fault condition. When it goes into the fault condition, you're going to see on the oscilloscope that the pulse width modulated voltage no longer modulates. It's going to hang up at 12 volts DC and provide too much power or pressure to your fuel system. So in that case, the module's not actually controlling that the power going to the fuel pump. And there's been a number of cases I've seen people complaining that there's cases where the Stage 2 fuel pump ruptures the fuel lines in the fuel tank. Sometimes that's caused by the Stage 2 fuel pump is a little longer, and the output hose of the fuel pump can bend very sharply and create a restrictive point, and the hose can rupture at that point. In other cases, there's not a kinked hose, and they're still either blowing the hose connectors off, or they're actually rupturing the hose itself because the fuel pump's running full tilt all the time. Okay, now we have the car running, and you'll notice on the scope that we have the pulse width modulated voltage driving the fuel pump. And you'll notice up here it's at 12 volts most of the time, but it goes down to 0 volts, reducing the power going to the fuel pump. As I rev the engine, you'll see that the modulation changes. And when under high acceleration, that provides 12 volts DC to the fuel pump, maximizing its output capabilities. Over here you'll notice that the current measured out of live data is running around 10 amps, and the meter that we put in place is saying 11. The live data is actually showing an averaged current level, so that's why there's a small difference between the two. As I rev the engine again, you'll see that those match much closer, because this is really measuring that peak current. So here we go. We're going to rev it up. They're both measuring 12 or 13 amps. What we'll do now is we're going to add the load resistor to simulate the Stage 2 fuel pump load on the control module. Okay, I just added the load resistor, and you notice here the control module went into a fault condition. We're just over 20 amps, and that's at the point where the control module goes into this fault mode. If we scan the ECU, what we'd see is there's a high current fault at the fuel pump control module. Even as I reduce the load, or the load goes down, the fuel pump control module is still locked into this 12 volt DC fault mode, and I can rev it. And you'll see it doesn't recover from that. So as you're driving around, basically you're putting maximum power into your fuel pump and overpressuring your fuel line. That's where that bursting can happen. Now we're going to switch over to the ET3 design Stage 2 fuel pump control module, and you'll see it has no problem with this 20 or 30 amp load that we'll show you. Important: disconnect the negative terminal of the battery. Step 2 is to remove the connectors from the control module. This is the fuel pump wires, input power and controller wires. Step 3, remove the module. Install your Stage 2 fuel pump control module. Then we're going to cut a couple wires, and don't panic, because these connectors and the terminals are available online. Got these guys, the terminal and the connectors, and the white ones. So if you ever did want to go back to your OEM setup, it's not impossible. So we're going to cut these wires real close to the connector itself. 1, 2, and we connect the power wires. Input power, again close to the connector, and we will strip about 0.3 inches off of each end. And insert them into the control module. So this is our fuel pump. If you can see here, the terminal block's labeled with fuel pump plus. Make sure there's no straggler wires. And so I'm using a torque screwdriver, which you don't really need to do, but I wanted to demonstrate roughly how much torque you need to apply to the terminal block. It's really very light. It's 4 inch-pounds of torque. If you have a torque screwdriver, go ahead and use it, but not necessary. The important thing is to not overly tighten them. It really should just be snug. Okay, that's all there is. So you notice this is a little tight, so you may need to add a little extra wire. So we're going to pop these two guys off. And what you may need to do is slice this retaining tape and both slide this up. There's plenty of slack in the wire, and then reattach the tape. And I probably won't do that here in video, but pretty straightforward. So now we have the input power wires. We're going to connect the ground up. Wires to that. This guy. So you want to make sure you strip enough of the insulation off so that the cage clamp on the terminal block doesn't pinch the insulation. It's actually attached to the wire, and then make sure they're snug, nothing loose there. This connector just plugs back in. That's all there really is to the installation. Now, ideally, this fan's able to circulate some air. So the shoulder cover that goes over here does allow some airflow. There's a plastic retaining clip that's in that shoulder bolster that goes in this hole. I recommend you just remove that. That allows some of the air to flow through here. Okay, so we're going to remove this plastic clip to try to help the airflow a little bit. This just pops out, and the shoulder pad will still fall in place. It won't pop out. If you wanted to help a little bit and increase the airflow, you could cut a little bit of this out so some air could flow up through here. And the last thing to do is reconnect the battery. You're all set. Okay, so we've installed the Stage 2 fuel pump control module, and we're running with the original OEM fuel pump. And you'll notice that the current level measured, the actual current coming out of the fuel pump control module, it shows 11 amps. However, the live data coming off the OBD2 port is half of that, and that's because the modifications we made to the module report half of the current to the main ECU so that it doesn't go into a fault condition until we get to 40 amps. So that's intentional. So if you're looking at your data with your scanning tool, remember that it's going to be showing you half the actual current level. So over here you'll notice that the pulse width modulated power's properly controlled going to the fuel pump. I'll rev the car up a little bit and you'll see that the modulation changes as it should. And now we're going to increase the current quite a bit to the fuel pump, simulating a Stage 2 fuel pump. So here we just got up to 25 amps actual, and I'm going to switch over here and we'll get a little higher, get up to 32 amps. And notice that we're 15 amps on the live data, but it's not real, it's half the actual value. Our pulse width modulated voltage going to the fuel pump's running fine. I'll rev her up. And of course, no fault condition. Fault condition wouldn't happen until we get to 40 amps. So everything's happy, our fan's running at low speed. There's really no problem with this control module running 35 amps all day long. ET3 Design has the right solution for you. Click on the Amazon link below.